Okay, so like I said, I started with 1,500 PDFs that were all somehow different from each other. Just downloaded off the internet. From each one of those, I made random mutations of them. I can't remember. You can do the math and figure out what it was. I think it was like, oh boy, I can't remember, 3,000 maybe of each. And I ended up with 3 million test cases to try to run through Adobe Reader. Run this through, of course, I get a bunch of crashes. Even though, remember, this is the most dumb fuzzing in the world, so it was really surprising that you see so many crashes. So they crashed, and I would record what instruction pointer it crashed at. So there were 100 different instruction pointers that it crashed. And if you look, and those 100 happened in 2,500 different crashes. And so less than, 0.1% of the files I tried actually crashed. So, that's okay. And then I had to figure out, what am I going to do with these 100, crashes? Are they unique? Are they exploitable? That sort of thing. And this is actually what my talk, so I'm going to talk at Black Hat. If you want to come to it, I hope you would. It's tomorrow, I think, tomorrow morning. So my talk tomorrow is like, okay, so I got all these crashes, now what do I do? But for now, let's see what I did then. So one thing I did was I could run it through, because Adobe Reader works on Mac and Windows. So I took the Mac version, and I ran it through libgmalloc, which is a way to try to catch buffer overflows early. So as soon as the buffer would be overflowed, you would crash, and that way you don't have things where you've corrupted memory and it executes for a little longer and then eventually dies. So that should be a way to sort of uniqueize the thing. So 34 different ones. So I reduced from 100 to 34 different crashes. And then Apple has this tool called Crash Wrangler that tries to say whether it's exploitable or not. And so of those 34, Crash Wrangler thinks 3 are exploitable. Okay. Other tools exist. So Valgrind is a tool. It can measure buffer allocations, and it can catch buffer overflows and that sort of memory corruption very early. It didn't work very good with Adobe Reader, for a reason you can't really see. The problem is that Adobe Reader has so many issues that it would complain even on clean files. So it was hard to separate the wheat from the chaff, so to speak. So it said there's somewhere around 20, but it's a way underestimate. And of those, 11 were invalid reads, 2 were invalid writes, 5 were uses of uninitialized variables, and 2 were just the process just died. Okay. And then I took these over to Windows, and in Windows there were 40 different crashes. And then I ran it through their tool, which is going to be talked about later, Bang Exploitable. And Bang Exploitable thought there were 33 unique crashes, so that's pretty close to what I got on the left hand side of the slide there. And of those, Bang Exploitable tries to figure out if they're exploitable or not. It says there's 4, probably not, 17 unknowns, 8 probablys, and 4 exploitables. All right. So again, just by doing dumb fuzzing, I found potentially 4 exploitable bugs in Adobe Reader. So that really shouldn't happen. All right. And then I go on to say some things about, so at this talk I was interested in how do the tools compare, what kind of things do you find with fuzzing, so sort of questions, like meta questions about fuzzing. And so I'll just run through these real quick, and again, if you're interested, check out my slides. So you can see here, so these are different tools and what they said. So there's only one crash that everyone agrees is bad. So Bang Exploitable thought it was exploitable, Crash Wrangler thought it was exploitable, and Valgrind thought it just died. And then there's some that one tool thinks is exploitable, one doesn't. And then there's some that doesn't even crash on Windows, but Crash Wrangler thinks it's exploitable, and all sorts of other things. So the tools don't agree. And this again is sort of what my talk is about tomorrow. Like, well, what do you do in this situation? Okay, what about how rare are crashes? So it turns out that one crash happened all the time, like 1,600 times. So there's no way you could possibly miss that. But some crashes were very rare. So of the 100 crashes, most of them occurred only one time, so they were very hard to find. Here's that same information, except in text form. So one crash was found 1,400 times at the bottom, 57 were found exactly once. So 57 were pretty hard to find. How important was the file choice to fuzz? So if you just download a random PDF and fuzz it, are you going to find bugs? Well, it turns out that you're not. It was really important to get all the PDFs. So remember, there were 100 different crashes just by EIP. Of all the 1,500 files, all those crashes occurred in only 192 files. So that means 87% of the time, if you download a PDF and fuzz it, you're not going to find any bugs at all. So maybe this is how Adobe does it. So most of the time, you download things and you don't find any bugs at all. It turns out if you download enough things, you would find some. Most of the files, it's not like one file finds lots of things. Most of the files only found 1 or 2 or 3 crashes. And so that means you really have to download a lot of files to use as your initial test cases. Okay, this is the same information in graph form. And then well, you know, I don't really care as a researcher about all the null pointer references. I really, you know, are the same statistics true if you only worry about exploitable bugs? And the answer is yes. So, so there's 2 files. Let's see. So there's 1 crash. So there's 4 exploitable crashes, right? The first one was found by 2 files. So most of them were found by 2 files, except the last one was found by 42 files. So again, it's hard to find an initial test case to find these, even to find a regular bug or an exploitable bug. Okay. So I'll start wrapping this up here. So the other question that comes up a lot when you're fuzzing, right? I said I generated 3,000 test cases per initial file. Why did I choose 3,000? Well, I just did the math, and that's how long it was going to take to run 3 weeks, and that's basically all the patience I had. So what would be a better way to do that? And the better way is you run so given a fuzzer, if I run it for 1,000,000 years, there's going to be a certain number of bugs it can find, right? So and probably if I run it for half that time, it's probably going to find about the same number of bugs, right? Because you know, at some point you've more or less tested everything. So you expect to find a curve like I have drawn here, where the longer you run, it sort of flattens out. So you're not after a while, you're not going to find that many more bugs because you've more or less exhausted all the things your tool is capable of finding. And so so the way you know to stop fuzzing is if you plot a curve like this, when it gets flat enough, then you stop. If it's still going up, that means you should keep fuzzing. So let's see if, you know, this is all just my idea of when to stop fuzzing. Let's see in practice whether you get a curve like that. So here's the curve on number of iterations versus number of crashes. So the blue line is just crashes in general, and the red line is for actually exploitable crashes, where exploitable is defined by being exploitable, not necessarily actually exploitable. So it does kind of look like I thought it might. And also you'll notice that it's not really flattened out quite yet. So I should have probably fuzzed for longer, and I would have probably found more bugs. All right, and then this is sort of a, you know, bad boys Adobe slide. So, so I started in October, and here's the bugs I found. And then like in December, Adobe came out with this, we've been fuzzing and we've learned lots of things about fuzzing, right? But then it turns out that, you know, so they released a new patch in January. I was like, oh, they probably found all my bugs. No, it turns out they didn't really find anything, right? They found one of the unknown ones. So they probably have more lessons to learn still. And then in February, they came out with another patch. And this one, they found 2 more unknowns. Or no, they found 1 more unknown, but one of the unknowns somehow got promoted up into a probably exploit. So something happened with that one particular bug. But anyway, so they have found some more bugs since then. I have actually been keeping track in a different deck, but this is an older deck. So, but anyway, so they're not making much progress. It's going to take a while to find all these bugs. All right, so I don't think I have time for preview, but I'll jump ahead to well, I'll just show you the one good slide. So this is the same slide as you saw for reader. So you'll see there's lots more bugs in preview. So I found 1,300 crashes, which reduced down to around 281 unique ones, of which 61 are exploitable. So lots of exploitable bugs in preview. And then finally, this is all the same stuff except for preview. And it turns out it's more or less the same, which is what you expect. Here's the curve, still going up, so probably even more bugs. This is them not fixing their bugs. So 228, 175. And here's me trying to calculate when they're going to have all the bugs fixed. 2012, they're going to be good to go. This is something. All right, so here's the final slide. So if you think about what PDF reader to use, there's probably not too much debate here, right? So Adobe Reader, it kind of didn't do so good, right? There's still lots of bugs in it, but Preview, there's way more bugs. So anyway, even dumb fuzzing can find this, so you can imagine if you actually really took your time and made some good test cases, what kind of bugs you would find. So anyway, that's it. Thank you.